Hello everyone and welcome back to another troubleshooting diagnosis video, and today we actually, I just got these two cards in at the same time, but I think I'll make two separate videos on them, and I think I'm gonna start with the 680 and then this 580 here later for the troubleshooting process. So I bought three cards as of late, like these two, and then this here DirectCU2, that's already in the process of becoming an E-Power. And I see the plastic cracked again, which was expected, but I'm still kind of disappointed. Anyway, yeah, this 580 was a dead core. The other 580 might still work out, and this one might still as well. So this here is a Gigabyte GTX 680 4GB actually. So you can see it has memory on the back, and it is using Samsung dodgy, same as my classified. So if I can fix this, I can SLI it with the classified, which will be very nice. So I think the original description for this was no video. So card turns on, but no image on screen. I hope we're gonna have like a minor rail that's not firing up here, because if this has memory corruption, this is gonna go onto the fix once I figure out how to properly reball memory chips pile. And this one's gonna be hard because it has memory chips on the back as well. But yeah, anyway. Also, this is a 3-slot card. And the heatsink, the heatsink is 2.5. That's really nice heatsink considering this is a 680. Also, the state of the card is really good condition physically. But yeah, let's take the card apart. So, gonna get my screwdriver. And we're gonna start taking the card apart. Sadly, I can't really put it down because of the 3-slot I/O shield. So I'm gonna have to hold it like this, but that's fine. This cooler should only have, it should only be these 4 screws, and then there's a VRM heatsink, and then this hold down bracket, which is probably there to prevent GPU sag. Yep. We have direct contact heat pipes. Interesting. And Gigabyte is using a non-standard controller. It's using an ADP 4100. Okay, I still have a datasheet for that though. Okay, thermal pads look fine. Thermal paste looks alright. Okay. Let's get the bracket off. Just gonna take everything off of this. So we can... Oh, this is loose. These screws are loose. If someone just swapped the thermal paste on this, I'm okay with that. But if someone, tried to heat gun this, or messed with this in a different way, I'm very disappointed. Because that's what happened to the 580 that's dead. Someone tried to reflow that card, and I don't know if the reflow did it or if it happened before, but that 580 is too far gone. All the rails work, the PCB is fine, but the card is not getting detected by the PC. It's not even booting up. When the card is inserted, it just straight up prevents the PC from starting. Okay, this has a very sticky thermal pad. There we go. Looks fine. Oh, this is a 6-phase. Interesting. I thought this was using the reference PCB just with the 5th phase populated, but no, this is actually a 6-phase. This is a PCB I haven't seen before. I mean, this is still mostly a reference PCB, but it's slightly customized. Interesting. Looks mostly fine. We do not have... No, we have a fuse for the PCI Express slot. We do not have fuses for the other inputs. Where's the INA 3221? Oh no, this is using INA 219s. Okay. So it has, this doesn't have the usual one power monitoring chip with 3 inputs. It has these, which are also power monitoring chips, but with just 1 input. So each shunt has one of these. So this shunt has this shunt has that one, and then this shunt has that one. Okay. But so far this looks physically in a pretty good condition. Slightly dusty, but physically pretty good condition. Okay, let's serial number. Not anything special. Okay, let's go to measure. So the first measurement you always do when troubleshooting a graphics card like this is you look for shorts. So we're gonna put one probe to ground. The IO sheet is a very nice way to get your ground. And when I touch anything connected to ground, the multimeter will beep. So if anything is shorted to ground, we will hear a beep. So let's check 12 volts from the PCI Express slot. It's not short. We have to check that fuse though. Is the fuse still okay? Yep, the fuse is okay. Then let's check 3.3 volts. That's from here, 4 pins. 1, 2, 3, 4. That's also okay. And then let's check the power inputs here. That's alright. And this one is alright. So we don't have any major shorts. Which now it would basically be safe to turn on. I always like to do also some resistance checks, so resistance check of the outputs of the VRMs. So output of our memory VRM. This has Samsung memory. This is not gonna be that big of a resistance if we get the... Sometimes a bit hard to measure. Let's take the capacitors instead. Yeah, 51 ohms or 52. That's more than I thought actually. But more is never bad. Too little is bad. Okay, let's check the V-core output. Also really doesn't wanna... 8 ohms. Well, I know these smaller Kepler cores have quite a high resistance, but I was expecting something more like 6 ohms. But that's, again, that's still okay. Then we have what's probably 5 volt regulator over here. That might be our BIOS chip. Then these two are probably our PEX rails. For some reason the 680 has 2 little converters that put out basically the same voltage. So it has these two, which should be... Well, I don't know if they're both technically PEX, but they both put out a very similar voltage. So I'm just calling both of them the PEX rail. And this might be connected to this. Usually there's like a 3.3 volt regulator up in this area. At least I think it's a 3.0. Well, let's check. That chip is an APL something. Yeah, that's usually like a smaller buck converter. And then this chip down here with the yellow dot, that's probably our BIOS chip then. Alright. So, we don't have any obvious shorts, don't have any obvious resistance problems. So, now we can turn the card on and check if, well, if it turns on, like if it just works, I'll take that. If it artifacts, that's a rip, because then it will be going into the fix later pile. And if it's not displaying an image, then this video will get a lot more interesting, because then we can take our voltage measurements and check if we, well, if it's not displaying an image, it's probably some rail that's not firing up. So we will get to investigate that. I've had a 680 before that had the this hex rail die, which I guess I could salvage a replacement chip for that. I might have some that I can get from other cards, or I'm just going to e-power it with like a small 4 amp external buck converter. Okay, that's clean. Any... Well, the SMDs are all there. The core looks fine as well. Like if the core has like a crack in it, that's that's a rip. But this looks fine. So I'll set the test bench up and we can do our voltage measurements. So I now have the test bench set up. I have the ground probe of the multimeter connected to the I/O shield, so we can take easy measurements. And let's turn the card on. No fire, that's good. I don't feel the core getting hot. Okay. Let's check voltages. We do not have V-core. Okay. We also don't have memory. Do we have what I suspect is 5 volts? It's gonna have to... Something's weird here. Oh! So the fuse is broken. There's no... Okay. Huh. Well, I suppose that's why we don't have any voltages. Let's check the chunks. So this one up here is probably the PCI Express one then. And then the other two are... This one's getting voltage. Well, this one's also dead. Wait. No, okay, this one has voltage. I was just measuring it wrong. So this one down here is the one that's dead. So this is the PCI Express lot 1. Okay. So turns out the fuse is actually dead, so no power nowhere, anywhere. Which means back to checking, because we might have a short behind that fuse. I still wonder why it beeped though. Why we got a beep from that fuse. Well, anyway, let's recheck the card. Okay, so now we found out that our fuse here is actually broken, which, let's just recheck that. Does it actually beep? Oh, maybe I was touching that capacitor. Yeah, maybe I was touching the capacitor. Anyway, now it's not beeping for the fuse. Yeah, I was touching that capacitor. Okay, so the fuse is blown. So let's check, are we short to ground on the other end of the fuse? We are. We have a short to ground on our PCI Express 12 volts. Okay, so this has just become a lot more interesting. Now we get to find shorts. So this is the inductor that it's connected to. Let's just see if this is shorted through to any output. Okay. No, this is measuring through ground, probably, because we are probably... So this short might be going... Is it shorted to V-core? That's also measuring through ground, probably. So this is shorted to ground. we have 0 ohms to ground. So somewhere 12 volts is getting shorted to ground. And the reason why we are seeing this resistance here is probably because this is going from 12 volts to ground through the memory chips to the output of the memory VRM. Because if it was shorted directly, you would see, yeah, this is the exact resistance from ground to the output. The resistance is probably different from before in the video because the card was really, really cold. From when I pulled it out, like it just arrived. And when the card changes temperature like that, the resistances can change. Yeah, core resistance also came down a bit. Yeah, so we get the same resistance here. Okay, I don't actually know where to look next. So something is shorting our stuff to ground. Is the is this maybe connected to? Okay, this is connected to, but that might also just be the ground side. I don't really have the pinout for this converter here, so it might be on any of the 12 volts. Let's check if it's... Okay, no. So we only have a connection here. I'm really not sure where to go next. So usually I would be expecting like an obvious short circuit in like one of the 2 VRMs. But we don't really have that. We don't have... because it's a direct short to ground. Like here. Usually when you have a short on 12 volts, like the... usually the short that happens is that the high-side MOSFET of one of the VRMs fails. And it fails closed, so it's closed always. So you would measure the resistance from 12 to grounds and you would see, say, the resistance of the core or the memory, depending on which of the 2 VRMs fails. But here we have like 200, 300 ohms. That's way too low to be the core or the memory. So it's not our VRMs that are failing. Something else is, and I'm not entirely sure what is. I might have to... Well, I don't really have a lab power supply, so I can't really check with voltage injection. So just about anything could have died here. Maybe it's one of those 2. I hope I'm getting this correctly. Is this the output? Well, that looks normal. And then this one should have the output here. That also looks normal. There could be a dead capacitor somewhere. Multilayer ceramic capacitors fail sometimes. I might have to take a closer look at the card. Maybe I'll find some physical damage somewhere, like a damaged capacitor. Yeah, I'll take a closer look. And I'll probably pause the video while I do, because this is just gonna take a while. So I'll take a closer look at the card, and yeah, I'll continue filming once I find something. Okay, so it's the next day, for me at least, for you it's the same video, and I have hooked up the freshly finished direct CO2 e-power up to the blown fuse on the PCI Express load. So I'm going to feed Specifically, I'm feeding the V-core voltage from this E-power into the short, which is slightly under 1 volt, for a technique that's called voltage injection. So this is the first time I'm really using voltage injection for something. And basically what I'm doing is I'm just feeding power into the short and then see what component on the PCB is getting hot. Now you could do it a bit more fancy. You could use a thermal camera, or you could also use a proper lab power supply, which would then tell you the current consumption, and from that current consumption, if you do it enough times, you will see, oh, this kind of looks like that component is shorted, because different components pull different amounts of current when they are shorted. But I'm doing the very basic but still working way of just going over the card with my hand and feeling if something gets hot. Now, I did find something. I do believe I found the root cause of our short right here. And that is this capacitor over here. Now I'll try to get a bit closer. Camera can't really get any closer than this. So here we have this little multilayer ceramic capacitor, which is a 12 volt input filtering capacitor for this phase of the memory VRM. And I did feel in this general area something get hot when I went over it with my hand. And to further find out which component in this area did actually get hot, I've seen this used by several people. They use rubbing alcohol, put it on the card and see where it evaporates first. You can find it out that way. I don't have any rubbing alcohol on my hand right now, which is why I just use some flux instead. So this stuff here, which I have just in this repurposed old thermal paste tube. So I put some flux on the input filtering capacitors. I kind of suspected the MOSFET might be short for a bit, but then I remembered that I was told that these input filtering caps tend to die a lot. And also I was feeling like a small heat spot when I went over the with my hand, not a very big one that's like a MOSFET size. So I put some flux on the capacitors here, and you might already be able to see which one did yield some results. So the one that I pointed to, you can see that the flux is like reflective, because the flux there liquefied, whereas on the other caps it's still in a sort of solid state. So I can test that again. Let's take the flux off. Put on some new flux, and then you can hopefully see how the flux will liquefy. So, when I now turn the power supply on, it's gonna take a while because there's not that much current going through it. But you should see how this left cap, the flux should slowly melt on the cap. Yeah, it is melting. You can I don't know how well it picks up on the camera, but I can see that it is slightly melting there. You might be able to like barely see it on the camera. It's I can't really get closer because the red cable is just too short. But yeah, you can also test it if you just take the flux and move it around a bit. You can see how on the right cap the flux kind of sticks to it, but on the left one it doesn't. On the left one it's just like, it doesn't stick to the surface of the left cap, but on the right one the flux, I'm going to take some flux here. Now on the right cap it does kind of stick, but on the left one it just goes right off, because the left one is heating up. So I think that is our culprit. And I'm going to remove this capacitor, and then hopefully we'll just have no more short. I could put a new cap there, but honestly I don't really think, well, if I was doing this for a proper repair, if I had like a customer bring this card in, if I wasn't repairing this card for myself but for someone else, I would put a new capacitor there. But since this card, just like all the other cards that I work on, are for my own personal use, I don't think I'll bother putting this cap on because the card will most likely be completely fine without it. Okay, I'll set up the hot air station then. I'll get the preheat set up, and then it should be pretty easy to desolder without risking to like pop any of these CAN type capacitors around here. Alright, until then. Alright, ladies and gentlemen, we have it. The short is gone. It was in fact that capacitor, so if we now go into continuity mode and check our 12V, it's no longer short, so 12 volt to ground is no longer short. And when we now go to our capacitor that we removed and we check that one, it's short. So, our short on PCI-E is gone. The only thing I need to do now to get the card working again is to replace that fuse. I'm not quite sure if I have a fitting one. I probably don't. So, my test bench power supply is pretty fast when it comes to overcurrent protection. I will trust the power supply. And I'll just bridge the fuse. Again, if you do this properly, do replace that fuse, but because again, this card is for my own personal use, I'm fine with doing a dodgy repair like this. But if you are doing this for anybody but yourself, or you want the card to be reliable, you should replace that fuse. I'm just gonna bridge it because I do not care for my personal use. This card is just getting benchmarked as well. So yeah, I'll do that now. Oh, the card's reassembled and in the test bench, and as you can see, we do have a picture, but it's artifacting. Now, one thing that also threw me off is this, because this is a gigabyte card, but it says EVGA on the BIOS. I do vaguely remember something about this card being described as being flashed with a Mac-compatible BIOS. So maybe, just maybe, we don't have a dead memory chip here, but actually just a wrongly flashed BIOS, and it wants to restart here and launch the GPU driver, which will crash the card. But other than that, we do take a lot of things. We have this configuration of memory. We have X16 Samsung chips. But it doesn't say which revision. We have the Samsung D-Die memory chips on the card. So, yeah, I guess it is time to find the correct BIOS for this and flash it. And if that doesn't fix the card, then, well, I guess it's another one for the fix once I learn how to swap out memory modules pile. Which I was really hoping this wouldn't be. I mean, this had a short on the input side of the memory VRM. Why should this have a problem on the output side? It shouldn't. It's just a short capacitor that... Yeah, I'm gonna hope that this is the BIOS. Yeah, you'll see if it is shortly. I'm not really sure what is happening here, but I rebooted the card after having some difficulties flashing the card in Windows 7, so I just booted it in Windows 10, and the card just works now. I didn't flash the BIOS, it's still on the EVGA one, which has a really low power target compared to the one it should have. The BIOS that is meant for this card is 260 watts, that's quite a difference. Really good core too. Okay, please Please just let this be like a BIOS issue. If this card works, this is gonna be amazing for overclocking. I will still flash the card though. I will save the BIOS that it has currently. But I want the proper BIOS for this card. Okay, we've stopped the graphics driver for extracting the BIOS. There we are. Alright, I'll just save this here. GK104. Oh, it's set to American. Where's the no? Ah. Okay, anyway, I'll do this off camera. I'll flash the proper BIOS onto it and then... so I now have NV flash working, and I'm just gonna confirm that we are flashing the BIOS now. Of course it does freak out because the board IDs are completely different, because this was flashed for a for an EVGA card, and this is a custom PCB only used by Gigabyte, so of course the BIOS is meant for a completely different PCB. Judging by the low power limit that we saw, it was probably a reference GTX 680 PCB, which it also said NVIDIA GTX 680 instead of GK104 board, so that might be supporting that claim. Okay, the BIOS is flashed, now we just need to restart, and the card will reload with the correct BIOS. Just wait a minute. There we are. And we're going to Windows 10 again, because that has the driver for the card. Windows 7 does, well, Windows 7 was, I don't know why it was artifacting. It artifacted before I was in Windows 7. I got artifacted on the boot screen, which you just saw does not artifact now. Oh yeah, it does. Oh, it actually does not have the driver because it's detecting the card as a different card now, because now, okay, it doesn't work yet. It should, yeah, that auto goes, auto install the driver, or auto initialize. There we go, now it should show up as the correct Gigabyte card. GPU is pretty slow today. Yeah, now we have the Gigabyte BIOS, and we should have our proper power limit of 260 watts right here. So, card's working. Let's run a stress test. So I'll just let's just give the card like a lot of stuff to do. Let's just max the power limit, give it full voltage extra. Well, I don't know how much it overclocks yet, but yeah, let's run some Firestrike. And see where that ends up. Yeah, I have really no idea why it was artifacting before. I really don't know. I hope it was just some weirdness with the Mac compatible BIOS. Like, I mean, it's a Mac BIOS and I'm using it on a Windows machine. Maybe there was some initialization problems. I don't really know. The card is working now and it is working under load correctly. I just hope it stays that way. Okay, let's just run a basic Firestrike as I always do. And, well, hopefully this will pass. There's really no reason for the card to have any more issues than... like, the issue the card had... Well, yeah, let's just use the time where the benchmark runs to go over the issue of the card again. So, the card showed up, the symptoms were not detected, no fan spin. And when we were testing the card, we found that on the PCI Express slot 12 volt there's a blown fuse, and the fuse blew because there was a short circuit on that 12 volt power plane. Now, I didn't really know where to go look for the short circuit, because usually when you see a short, it is shorted through, say, the vCore or vMem VRM. So when you measure the resistance from the shorted 12 volt power plane to ground, you see either the core or memory resistance, depending on what it is shorted through. But we actually saw a complete dead 0 ohm short. So it wasn't shorted through any of the high-set MOSFETs of the VRM. It was in fact shorted through something else. And to find out what it was shorted through, we did voltage injection. So you use an external power supply and you feed a low voltage current into the card. So we weren't feeding full 12 volts into it, because that would have probably blown up the cap, would have just caught on fire, might have broken more things. And it also surely would have incinerated the small red cable that I was using for the voltage injection. But yeah, by just sending slightly below 1 volt into the PCB, you were able to, just by touching different parts of the PCB, were able to find out that something in the area of the lower memory VRM phase was getting hot. And to further narrow it down, most people should use isopropyl alcohol. I didn't have any on hand, so I used flux instead. I put flux on some of the capacitors because I have heard before that these input capacitors tend to die. And yes, it was one of the input capacitors. One of them had the flux melt on them, whereas on the others it stayed more or less solid. I removed that capacitor. I should have replaced it with a new capacitor if I did this like for someone. If I took money to repair someone's graphics card, I should have replaced that. But as it stands, I bought this card for myself to use it for my overclocking. And I'm completely fine with it missing one input capacitor. It can work without it, as you can see. So I did not replace that capacitor. And yeah, and now the card works just fine, even though it artifacted for a minute there, which I don't know why it did. I'm just hoping it had something to do with the BIOS that was flashed onto the card, which was not actually meant for this card. And yeah, we have now returned the card to its proper BIOS, and we are also nearing the end of the benchmark, and it looks just fine. So, I think I can say that we had the good ending here. The card is working just fine. Well, I'm gonna still test it for a little more, but I have no reason to believe that the card would have issues down the line. The issue we had was a very straightforward short circuit capacitor. We removed that. Now there's no reason for the card to have any more issues. So there we go. Scores look okay. My CPU score is very low again for a 5.1 GHz 8700K, which is why I have my Windows 7 installed. This Windows 10 is trash for your benchmark scores. But anyway, the card works. The GPU score checks out for a stock GTX 680. So yeah, thank you for watching. I hope you learned something. This is basically what I'm hoping for whenever I buy a card to repair it. Something like this, like a nice straightforward issue that takes some finesse to find, but once you find it, you can solve it and have the card work again, just like this. That's what I'm looking for when I get cards like this. So yeah, thank you for watching. I hope it was entertaining somewhat, and until next time, goodbye.